Let's talk about collisions. What you're seeing here is Jupiter. But this is Jupiter in infrared, right after the Shoemaker-Levy comet ran into Jupiter, and you can see a number of different impacts as that comet broke up and then impacted Jupiter as it rotated. Jupiter's not the only thing that gets hit out there, though. So do we. So let's take a look at what happens when objects collide with the planets. So this, again, Shoemaker-Levy impacting on Jupiter. Okay. As the objects get closer to Jupiter, they do break apart. So this is why you get those number of different impact sites as it goes. Is there a mark left over from this object? Of course not, right? Jupiter has this nice gas cloud atmosphere, so we're not seeing any impact from that. But imagine if this had hit one of our terrestrial planets. Likely comets are seen, or the evidence of comets hitting other planets and moons are out there. This is one on Earth's moon and then on Callisto, a moon that goes around Jupiter, where you can see there's like a little chain, right? A little line of impacts likely from a comet nuclei, right? Remember, they're kind of like a kitchen sponge, right? They're porous, they're not solid. So as they get closer and closer to something that has a gravitational pull, that gravitational pull will just destroy them, and you'll get this chain of debris, or this chain of marks that you're seeing here. Earth is also hit by things. Not a whole lot of impacts remain on Earth, though. One of the more famous one is this Barringer crater here in Flagstaff, Arizona. It's a little bit hard to see how big it is, but you can see, of course, the road leading up to it. There's a little building there, right? This is a big, massive crater out there. Probably formed about 50,000 years ago when something that was maybe about 90 meters in diameter crashed down into the surface. How big is 90 meters? Well, we're talking about 300 feet. There's another one up in Canada. This one's kind of interesting. This is a lake that's around there. Just kind of the wildest thing, right? You can see that really circular shape there. Pretty interesting there. Other impacts that have happened on Earth. Remember the dinosaurs? We think that happened fairly close to us here on the Yucatan Peninsula. There's an area there on the very end of the Yucatan Peninsula where when you do some gravitational mapping, you see this nice circle shape. We think this is possibly where that impact occurred that ended up destroying the habitation for the dinosaurs, right? It didn't come down and kill the dinosaurs directly, but they think caused major climate change, which then killed the dinosaurs. Sometimes things are seen out in the sky that don't actually make it to the ground. So let's take a look at a couple of these videos. And you could just see at the end there where it creams her car there.
We have developing news from Western Canada tonight, where it appears a meteorite has fallen to Earth. There have been hundreds of reports of a massive fireball lighting up the sky somewhere between Melfort, Saskatchewan and Lloydminster on the border with Alberta. The security camera at the CTV Edmonton station captured stunning images of the fiery object as it fell to Earth. Now let's take another look. A search for the landing site is now underway.
So you saw there a couple of fireballs. So these fireballs are bigger objects that are colliding with our atmosphere. As they collide with our atmosphere, you get that amazing bright glow. And you saw in that second video where it lights up like daytime as that object comes in. One of the bigger events is the Tunguska event. This happened out in Siberia. This is very similar to the incident that happened around Valentine's Day, I believe in 2013, again out in Russia. This object likely impacted the Earth, but only after it really impacted the atmosphere in such a way that it destroyed a large area. So let's take a look at what it actually did. Okay, so we had a big object coming in the sky, and you can see the path of that meteor marked out here. As it gets closer and closer, like that fireball, it's going to make a nice big hot fireball flame there. Okay, that fireball flame is coming from the compression of the atmosphere. Okay, so it's compressing the atmosphere, creating a shock wave. This shock wave blows down trees in this green area you're seeing. In the red area, those trees are burned down. Okay, so it's knocking down trees, it's burning trees in a big area, right? The area of about a city. Okay, this is likely a big asteroid that came in and did this. According to the current math, we're talking about a comparable energy release to a 12 megaton nuclear weapon, right? This is a big, big thing. This is like that event from February of 2013. Again, also in Russia. Let's take a look at the video of the Tunguska event. Now, this is a little silly, so I include it for some humor purposes as well.
Tunguska, July 30th, 1908. In a remote area of Siberia, the morning calm was rocked by an explosion. The powerful blast was heard 1,000 miles away.
There was an enormous fireball blast, something on the order of 15 megatons of equivalent energy, which is roughly 1,000 times that of the Hiroshima blast at the end of the Second World War. This was an extraordinary event.
Because of the remoteness of the Tunguska region, it was almost 20 years before any government researchers visited the site. The first expedition to reach Tunguska was headed by Russian mineralogist Leonid Kulik.
When the initial expedition got to the Tunguska area in 1927, the natives were reluctant to show the scientists into the region because they thought the god Agdi had devastated the area because of the wickedness that was going on, and he had destroyed the trees, killed the animals.
Kulik eventually convinced locals to direct him to the blast location. Believing a meteorite had caused the massive explosion, Kulik assumed he would find a crater at the point of the meteorite's impact. To his surprise, there was none.
He looked for meteorite samples on the ground because often when an object hits the Earth, it throws up debris, and the debris is recoverable around the edges of the crater. But of course he didn't find that either.
What Kulik discovered has stirred UFO debate for decades. At the blast's epicenter was a frozen swamp with an untouched clump of fully grown trees in the middle. Circled around the grove, 10 million dead trees lay in a symmetrical ring, seemingly mowed down by a cosmic scythe.
So here we have an enormous blast site with no crater, no fragments or meteorites around the rim of the crater, and this radial pattern of burnt trees knocked down for some 20 miles in all directions.
In the years that followed, others traveled to Tunguska to study the unusual occurrence.
There might have been fruits obtained by labors of another expedition sent by the head of the Soviet secret police in the late 1940s. But all we know is that such expedition existed. We do not know what has happened to the items and information it collected.
Further baffling ufologists were reports of radiation damage in the Tunguska blast region.
There were also some reports of mutations taking place in plant life, and even some humans apparently suffered some gene damage.
In 1947, Russian Army Colonel Alexander Kazantsev developed a remarkable theory based on information about the devastating consequences of America's atomic bomb attacks on Japan.
и слушал радио.
He was listening to the report about the nuclear bombardment. The announcer gave a very long and very detailed description of how and in which direction trees, houses had fallen, and so on, how everything was hit. He realized that what had happened in Hiroshima, exactly the same happened at Tunguska, only nearly half a century ago.
Kazantsev hypothesized that the nuclear-like devastation seen at Tunguska must have been caused by the crash of a nuclear-powered alien spacecraft. But the scientific community rebuffs the UFO theory. Scientists claim the Tunguska explosion was caused by a rare but explainable natural event. They believe an asteroid dropped to just 3 miles above the Earth's surface and then exploded.
As the object came in, it was being decelerated and squeezed by atmospheric forces. It blew up with the force of a hydrogen bomb. The shock wave smashed down the forest, knocking trees away from the blast and resulting in a pattern away from ground zero.
But how would an asteroid explosion explain the reports of radiation damage in the Tunguska area? Scientists say it can be attributed to the sheer magnitude of the explosion.
As we mentioned before, the blast itself was 1,000 times greater than the Hiroshima blast at the end of World War II. The blast would have generated a series of very high-speed charged particles and would have been the cause of some of the mutations in the gene structures of plants and animals.
But to this day, scientific explanations do not satisfy many ufologists.
I have been several times to the place where the Tunguska body fell. I intentionally call it body, not meteorite. I mean, the catastrophe of an asteroid, of a comet, or of any other natural body cannot lead to such consequences.
A number of expeditions found things that they couldn't explain. There are some people who were saying that the evidence suggested this was some kind of an alien spaceship. That was the kind of magical explanation you use when you don't have enough real science to understand the physics and the astronomy involved.
So here's the known impact crater sites that we have across the world. You can see there's a lot of them in the North American continent. We've got a bunch in Europe, and then a whole bunch in Australia, and not a whole lot in other places. Now, that's not because those impacts aren't evenly spread. This is the known sites. So there's probably lots and lots of impact craters that we just don't know about, right? There could be many in China or Russia, South America with all the jungles, maybe in Africa that we just don't know about. We just haven't located out there. So it's a little bit misleading, this map. The other thing to think about is, like, you look at the density of impact craters here, and let's say this in northern Europe here, think about this kind of density, but all over the world, right? Meaning there's lots and lots of stuff falling into the oceans all the time, right? That's how we get to that many tons falling onto the Earth every single day, right? It's an astounding number of items that impact the Earth. So lots and lots of impact craters. Again, the biggest one that you can go see, the closest to us, is that one out in Arizona. A nice big impact crater out there.